Okay, so the question for this video is, are gravity and normal force an action-reaction force pair? As a reminder, action-reaction force pairs are from Newton's third law. That's the one that goes for every action. There's an equal and opposite reaction. And it's a question that I think makes sense, and it's one that I've heard asked in class, and it's one that I know a lot of people can get confused on easily. And that's because if we have, let's say, an object is just like sitting on a table. Let's say our table is black. I was looking for a brown table, but there is no brown in this program. So we know that gravity acts on our object, of course. And we also know that if it's sitting on this table, if those are in contact and this object is not falling through or anything, that a normal force is also exerted on this object by this table or whatever stable surface. It could be on the ground or anything that's keeping it from falling. Now, if these are the only two forces acting on this object, then these are also equal and opposite, and Newton's third law says that these action-reaction forces are equal but in opposite directions. So it seems like normal force and the force of gravity should be an action-reaction force pair. But there are a couple important reasons, or really sort of maybe just one important reason, why they aren't. And that's that both of these forces are acting on the exact same object, whatever this object is that's sitting on the table. Action-reaction force pairs are all about how two different interacting objects affect each other and how they exert forces and how they sort of interact. So if we look at just the force of gravity, right? The thing that exerts this force of gravity on this object is the earth beneath it. So the reaction force would not be like the table pushing this up, because the action force, if we write it out, and I should write that out right here, the action force for this is the earth exerts a downward force on the object, and then the reaction, again following the same structure that we always do for these action-reaction force pairs, is going to be the object exerts an upward force on the earth. And so if I wanted to draw that, this color, I could draw that here. And these two forces should in fact be equal and opposite. So actually the force that this object, whatever it is, exerts on the earth is equal to its own force of gravity that the earth exerts on it, and it happens to be equal to our normal force too, just because of the physical situation that this object is in. That wouldn't always be true. There wouldn't even always be a normal force, but these two forces being equal would necessarily be equal. The normal force, on the other hand, if we move over and focus on our normal force, that action-reaction force pair has a different sort of origin. Our action force there, what we can sort of see happening, what we drew on this, was the table exerts an upward force on the object, and then the reaction, again, following the same structure that we always do for these action-reaction force pairs, we switch the roles and then flip the direction opposite. So now it's not what the table does to the object, now it's what the object exerts on the table. Downward force on the table. So if we wanted to draw that, it would happen. Then we could just with this. So we can have a downwards force that this object, whatever it is exerting on this table as it sits on top of it. And this is also going to be equal to our normal force, which in this case just happens to be equal to gravity and to this force of gravity that the object exerts upwards back on the earth too. But these, and I should have color-coded these a little more carefully, but these two forces, right, that's a force pair, what the object and the earth are doing to each other, because that's two interacting objects. But our force pair for normal force is what this object and the table do to each other. Right? Gravity and normal force aren't two objects doing things to each other. That's multiple objects doing equal and opposite things to the same object. It's a very different sort of like relationship between the Earth and the table than it is between the object and the table, or the object and the Earth in these free body diagrams. So that all is why our gravity and normal force are not an action-reaction force pair. One, they act on the same object. Two, for gravity, that the reaction force pair would be the object getting pulled down by the Earth, and then the Earth being pulled slightly upwards by the object. And for normal force, the action would be what the table does to the object, and the reaction is just what the object does to the table, not a force of gravity.